Every long-exposure photograph of the night sky tells you the same comforting thing. The universe is full. Point a powerful enough telescope at any patch of dark, wait long enough, and galaxies appear, stacked behind galaxies, thousands of them in a sliver of sky no wider than a grain of sand held at arm's length. So you have come to believe, reasonably, that the cosmos is crowded everywhere, and that the fullness you see is the fullness that is there. But there is a place, 330 million light-years wide, where the galaxies almost completely run out, and anyone born at its center would look up, reason carefully, and conclude that their single galaxy was the entire universe. They would be wrong, and the most unsettling part is that they would have no way of knowing it, because the thing hiding the rest of the cosmos from them would leave no trace at all. Get comfortable. Hit subscribe if you're new here, because by the end of this, you will never again trust an empty sky to tell you that it is empty. Now, let's slowly ease into this. Part 1. The sky you think you know. The universe you picture when you close your eyes is a crowded place. You imagine galaxies scattered everywhere, like the lights of a city seen from an airplane at night, too many to count and too far to reach, but unmistakably there, filling the dark in every direction. You have seen the photographs. You have seen the long exposure images where a single small patch of sky, no bigger than a grain of sand held at arm's length, turns out to be packed with thousands of galaxies, each one a wheeling island of 100 billion stars. And from those images, you have drawn a quiet, reasonable conclusion. The conclusion is that the universe is full. Everywhere you look, if you look hard enough and wait long enough, something looks back. You trust your sky. That is the assumption underneath everything you believe about the cosmos, and you have almost certainly never questioned it, because there has never seemed to be a reason to. The sky has always behaved like an honest witness. When you stand outside on a clear night, far from the glare of streetlights, you see a few thousand stars, and you assume those few thousand are a fair sample of what is really out there. When astronomers turn their instruments toward the dark and find galaxies stacked behind galaxies, you assume that this too is a fair sample, that the universe is the same kind of crowded everywhere, that your particular window onto it is an ordinary window opening onto an ordinary view. Tonight I want to gently pull on that assumption, because there is a place in the universe that breaks it, not a place that is dangerous, and not a place that is hiding anything, a place that is simply, almost unimaginably, empty. And the reason it matters is not the emptiness itself. The reason it matters is what that emptiness would do to anyone who happened to be born inside it. It would hand them a sky that looked complete and told them a lie, and they would have no way of knowing. They would trust their sky exactly as you trust yours, and their sky would quietly convince them that the universe was far smaller and far lonelier than it truly is. Let me start with how reasonable your assumption actually is, because I do not want you to feel foolish for holding it. You hold it for good reasons. For as long as human beings have had telescopes pointed in different directions, the universe has looked statistically the same wherever we aim. Point a large telescope at the constellation of the Hunter, and you find galaxies sprinkled across the background. Point it at the Great Bear, and you find galaxies there too, in roughly the same numbers. Point it straight up, straight down, toward the rising sun, or away from it, and the distant sky keeps delivering the same answer. Galaxies, everywhere, in comparable abundance. Astronomers even gave this idea a formal name. They call it the cosmological principle, the assumption that the universe, on large enough scales, looks the same in every direction and from every location. It is one of the foundations of modern cosmology, and for the most part it holds up remarkably well. So your instinct is not naive. It is the same instinct that professional astronomers built an entire science upon. If the sky looks evenly populated in every direction, then it is natural to conclude that the universe is evenly populated and that you, the observer, occupy an unremarkable spot inside an evenly filled cosmos. The crowd you see is the crowd that is there. The fullness is real. But notice the hidden move inside that reasoning, because the whole story tonight lives in that one small move. You are taking what you can see and assuming it represents what you cannot. You are taking the sample your location and your instruments happen to deliver, and you are treating it as the truth about the entire universe. Most of the time, that move works. The universe really is fairly even on the largest scales, but the move only works if your location is typical. And here is the quiet problem that almost no one stops to consider. You have no way from the inside to check whether your location is typical. You can only see what your sky shows you. You cannot see what your sky leaves out, and if your sky leaves something out, it does not leave a gap or a smudge or a warning label. It leaves nothing at all, which looks exactly like a sky that was never meant to contain anything more. Hold that thought, because it is the thread that runs through everything that follows. An absence leaves no mark. When something is missing from your view, you do not see a hole. You see a perfectly ordinary, perfectly believable patch of dark, and you have no reason to suspect that anything is supposed to be there. A missing galaxy does not glow faintly to remind you of its absence. It simply is not there, and the place where it is not there looks identical to the place where nothing was ever there in the first place. This is the strange and almost invisible weakness in the way every observer, everywhere, learns about the universe. We can study what is present. We are nearly blind to what is absent. Think about how this works in ordinary life, because it is gentler to feel it first on a human scale. Imagine you grow up in a small town in the middle of an enormous, empty plain, and the nearest other town is so far away that you can never see its lights, never hear it, never find any trace of it. You would not grow up feeling that something was missing. You would grow up feeling that your town was simply the world, complete in itself, because the absence of the other town would announce itself in no way whatsoever. You would not look out at the dark plain and sense a town hiding beyond the horizon. You would look out at the dark plain and see a dark plain. The other town would not be hidden from you by anyone. It would be hidden from you by distance, which hides things for free and asks no one's permission. Now lift that same idea off the surface of the earth and set it loose in the cosmos, because that is exactly where we are going. There is a region out there where the nearest neighbors are not one town away across a plain, but hundreds of millions of light years away across an emptiness so large that the human mind has no honest way to picture it. And anyone living near the center of that region would face precisely the situation of the child in the lonely town, except magnified to the scale of the entire universe. Their sky would be honest. Their sky would also be nearly empty of everything beyond their own galaxy, and they would trust it, because it would give them no reason not to. I want you to sit with how unsettling that is before we even name the place. It is not that such a sky would be wrong in any obvious way. It would be a faithful report of the light that actually reaches that location. The telescope would not malfunction. The observer would not make a mistake. Everything would be done correctly, and the conclusion would still be false, not because anyone erred, but because the evidence itself was quietly incomplete in a way that no amount of careful looking could reveal. That is a different kind of being wrong than we are used to. It is not the wrongness of a bad measurement or a sloppy argument. It is the wrongness of a perfect measurement of an edited reality. So here is the question I want to carry with us into the dark tonight. If a sky can be completely honest and completely misleading at the same time, then how does any observer, anywhere, ever know whether the universe they see is the whole universe or only the small, local portion that their particular corner of space, and their particular generation of instruments happen to allow? You cannot answer that from your chair. Neither can I. And neither, it turns out, could the astronomers who first stumbled onto the emptiest well-known patch of our cosmos more than 40 years ago, when they were not looking for emptiness at all. They were counting galaxies, the way you count a crowd, fully expecting the crowd to be there. And then, in one direction, the crowd simply stopped. Part 2. The Night. A survey found nothing. The year was 1981, and 4 astronomers were doing something that sounds almost tedious, until you understand what it really is. Robert Kirshner, Augustus Oehmler, Paul Schechter, and Stephen Schechtman were conducting a redshift survey. That phrase deserves a moment, because it describes one of the most quietly powerful techniques in all of astronomy. When you look at a distant galaxy, you can spread its light out into a spectrum, the way a prism spreads sunlight into a rainbow, and in that spectrum, you can read how fast the galaxy is moving away from you. The faster it recedes, the more its light is stretched toward the red end of the spectrum. And because the universe is expanding in a very regular way, the speed of recession tells you the distance. Measure the redshift, and you have measured how far away the galaxy is. Do this for enough galaxies, and you are no longer making a flat photograph of the sky. You are building a 3-dimensional map of where things actually sit in the depths of space. That is what these 4 astronomers set out to do, in a particular region of the sky, in the direction of the constellation Boötes, the herdsman, a quiet patch of the northern sky between the Great Bear and the bright star Arcturus. They were not hunting for anything strange. They were sampling galaxies, measuring redshifts, filling in the map, expecting to find what everyone expected to find everywhere, which was the usual even sprinkling of galaxies at every distance, the ordinary crowd, the fair sample. They were, in effect, taking a census of one neighborhood of the universe, confident that the neighborhood would look like all the others. What they found instead was a gap. As the redshift numbers came in and the map filled out, one enormous stretch of distance in that direction simply refused to populate. The nearer galaxies were there, the farther galaxies were there, but in between, across a span of distance that should have been thick with galaxies, the map stayed almost completely blank. It was as if they had been counting a crowd walking down a street, and partway along, the crowd had vanished, and then resumed again much later, leaving a long, silent emptiness in the middle where there should have been thousands of faces. The region they had found became known as the Boötes Void, and its scale is where the story stops being a technical curiosity and starts becoming something that touches you. The void is roughly spherical, and it measures about 330 million light-years across. I am going to ask you to slow down on that number, because it is so large that it slides past the mind if you let it. A single light-year is the distance light travels in a year, moving at the fastest speed anything can move, about 9.5 trillion kilometers. The nearest star to our Sun is a little over 4 light-years away, a distance so great that our fastest spacecraft would take tens of thousands of years to cross it. And the Boötes Void is not 4 light-years across. It is 330 million light-years across. Light itself, the fastest thing there is, needs 330 million years just to traverse it from one side to the other. To give that span some footing, consider that our entire home galaxy, the Milky Way, with its few 100 billion stars, is only about 100,000 light-years across. The Boötes Void is more than 3,000 times wider than our whole galaxy. You could line up over 3,000 Milky Ways edge to edge across that emptiness, and you would still be crossing nothing but dark. It is not a gap between stars. It is not a gap between galaxies. It is a gap large enough to swallow thousands of galaxies whole and leave no sign they were ever missing. And the center of this enormous emptiness is not next door, but it is not unreachably far either in cosmic terms. It lies roughly 700 million light-years from Earth. That means the light we receive from the edges of the Boötes Void today left on its journey about 700 million years ago, long before any dinosaur walked the Earth, when the most complex life on our planet was still soft-bodied creatures in ancient seas. We are not looking at the void as it is now. We are looking at a portrait of it from the distant past, which is true of everything we ever see in the sky, and which will matter more later than it might seem to now. Here is the part that turns the scale into something almost eerie. In a region of space that size, at the ordinary average density of the universe, you would expect to find a great many galaxies. The estimates vary depending on exactly how you count and what spacing you assume, but they land somewhere between roughly 2,000 and 10,000 galaxies for a volume like that. That is the crowd that should be there. That is the fair sample. And when the astronomers first counted what was actually inside the Boötes Void, they found about 8 galaxies, where thousands belonged. Decades of deeper, more sensitive surveys since then have raised the count, and today we know of roughly 60 galaxies scattered through that immense bubble. But 60, against an expectation of thousands, is not a crowd. 60 galaxies spread across 330 million light-years is a level of emptiness that has no equivalent anywhere in your daily experience. It is the cosmic version of finding a single scattered handful of people inside a city built for millions, and otherwise nothing but silence and empty streets reaching to the horizon. People sometimes call it the Great Nothing, and the nickname has stuck because it captures something the dry numbers do not. This is not a slightly underpopulated region. It is one of the largest known holes in the structure of the cosmos, a place where the universe, for reasons we will come to, almost forgot to put anything at all. And the strangeness of it is not that it is frightening, it is that it is so quiet, so featureless, so utterly without drama. There is no edge you could see, no wall, no sign announcing that you had entered the emptiest, well-mapped place in our corner of creation. There would only be the dark, looking exactly like the dark looks everywhere else. I want to return for a moment to that idea, because it is the same thread from before, and it tightens here. When those astronomers found the void, they did not find it by seeing something. They found it by carefully measuring the absence of something. The void did not show up as a feature on a photograph. It showed up as a stubborn blank in a three-dimensional map, a place where the expected galaxies failed to appear. If they had simply taken an ordinary picture of that patch of sky, they would have seen stars in the foreground, a few faint smudges, and a great deal of darkness, and they would have had no reason at all to suspect that an emptiness the size of 3,000 galaxies was sitting right there in front of them. It took the painstaking work of measuring distances, one galaxy at a time, to reveal a whole that was, by its very nature, invisible. An absence leaves no mark. Even when the absence is 330 million light-years wide, you have to work to notice it is there. So we have our place. We have the Great Nothing, 330 million light-years of almost perfect emptiness, 700 million light-years from home, holding 60 galaxies where thousands should be. And now we can ask the question that this whole night is really about. We have looked at the void from the outside, the way the astronomers did, as a curiosity in their data. But what would it be like to look at the universe from the inside of a place like that? What would the sky teach a mind that opened its eyes at the center of all that nothing? To answer that, we first have to feel, honestly and without flinching, just how large the emptiness around such an observer would be. Part 3. A hole the size of nothing. Let me try to build the emptiness up around you slowly, because the only way to understand a void this size is to approach it the way you would approach a cliff edge, one careful step at a time. Start with something you can almost hold in your mind. The distance from the Earth to the Moon is about 250,000 miles, and it took the Apollo astronauts 3 days to cross it. That distance already feels large. Now stretch it. The distance across our entire solar system, out to the farthest reaches where the sun's influence finally fades, is so great that the spacecraft we launched in the 1970s, moving at tens of thousands of miles per hour, have only just begun to leave it after nearly 50 years of flight. And the solar system, enormous as it is a single grain of sand compared to the galaxy that contains it. Our galaxy, the Milky Way, is about 100,000 light-years across. Within it, the stars are separated by a few light-years each, which means that even the nearest star to the Sun is so distant that its light, travelling at the fastest speed the universe permits, takes more than 4 years to reach us. The galaxy holds a few 100 billion of these stars, woven together by gravity into a slowly turning spiral, and from inside it, on a dark night, you see only the nearest few thousand as individual points, with the more distant billions smeared into the soft band of light we call the Milky Way itself. That single galaxy is already far larger than the human imagination can honestly contain. Now take that galaxy, that immense pinwheel of a few 100 billion suns, and use it as your ruler. The Boötes Void is more than 3,000 times wider than the whole Milky Way. If you shrank our entire galaxy down to the size of a single coin and laid it on a table, the Boötes Void at the same scale would be a circle wider than a large house, and inside that circle you would scatter only about 60 coin-sized galaxies, most of them clustered loosely toward the middle, with enormous empty stretches between them, where you could wander for the equivalent of hundreds of coins' width and find nothing at all. That is the texture of the place. Not empty like a quiet room, but empty like an ocean with 60 boats in it, where most boats cannot see any other boat in any direction. I keep returning to that comparison with thousands, because it is the part that refuses to feel real. At the ordinary density of the universe, a volume that size should hold somewhere between 2,000 and 10,000 galaxies. The void holds around 60. That means the Boötes Void is missing something like 98 or 99% of the galaxies it should contain. It is not slightly underpopulated. It is almost entirely vacant, drained of nearly everything that the rest of the universe takes for granted. If you took an ordinary patch of the cosmos and removed 99 out of every 100 galaxies, leaving only a scattered remnant behind, you would have built something like the Boötes Void. And the universe built it without anyone's help, for reasons we will come to, simply as a consequence of how matter has arranged itself over billions of years. Here is a detail that makes the emptiness even more haunting in a quiet way. The roughly 60 galaxies that do exist inside the void are not spread out evenly. They tend to lie along a loose, thread-like arrangement running through the middle of the void, as though a few faint strands of structure managed to survive inside the great emptiness. This tells us something important, and we will lean on it later. It tells us that the void is not truly hollow, not scrubbed perfectly clean. It is deeply underpopulated, drained of almost all its matter, but a few threads remain, like the last fibres left when most of a fabric has been pulled away. The void is not nothing. It is very nearly nothing, which is a different and stranger thing. I want to pause and let you feel the silence of such a place, because the numbers can make it sound abstract, and it is not abstract. Imagine you could be transported to a planet somewhere inside the Boötes Void, orbiting one of those few scattered galaxies near its center. You step outside at night. Above you, the sky is full of stars, because you are inside a galaxy, and a galaxy is a crowded place on the inside, with its own few 100 billion suns. Nothing about your immediate night sky would look strange. You would see constellations, a band of light across the heavens, the ordinary furniture of a galactic night. By the evidence of your unaided eyes, you would live in a perfectly normal universe. The strangeness would only begin when you tried to look beyond your own galaxy. From where we sit, in a fairly ordinary part of the cosmic structure, when our astronomers look past the edge of the Milky Way, they find neighbors. The Andromeda Galaxy is close enough that on a dark night you can see it with your unaided eyes, a faint smudge of light that is actually an entire galaxy 2.5 million light-years away. Beyond it lies a whole local group of galaxies, and beyond that, clusters, and beyond those, the galaxies stacked behind galaxies that fill our long-exposure images. But an observer near the center of the Boötes Void would look past the edge of their own galaxy and find, in almost every direction, nothing. No bright neighbor like Andromeda, no nearby companions, just darkness, reaching out for hundreds of millions of light-years before the first faint galaxies of the void's distant walls would even begin to appear, so dim by then that only the most patient and powerful instruments could ever detect them. Think about what that absence would mean to a curious mind. It would not look like a mystery. It would not look like a hole. Remember the thread we keep returning to. An absence leaves no mark. The void dweller, gazing past their galaxy into the dark, would not see a great emptiness announcing itself. They would see exactly what you see when you look at the dark between stars, a quiet, featureless black, perfectly ordinary, perfectly believable. The thousands of missing galaxies would not haunt that sky. They would simply be absent, and the absence would be indistinguishable from a universe that had never contained anything more than a single galaxy in the first place. This is the moment where the void stops being an astronomical curiosity and becomes something closer to a parable. We found the void from the outside, with careful measurements, knowing already that the rest of the universe was full, so we recognized the emptiness for what it was, a hole in an otherwise crowded cosmos. But a mind that grew up inside the void would have no such knowledge to compare against. They would have only their sky, and their sky would tell them, with complete and honest consistency, that the universe was small and dark, and theirs alone. They would have every reason to believe it. And they would be wrong, not through any failure of intelligence or care, but because the truth had been quietly edited out of their view before they were ever born. So let us go there, fully, and stay a while. Let us stop describing the void from the safe distance of our own well-populated sky, and instead stand inside it, under that honest and lonely heaven, and ask what such a sky would actually teach the beings who lived beneath it. Because the answer is not a small thing. The answer reaches all the way down to what those beings would believe about the nature of reality, the size of existence, and their own place within it. And it begins with a single, almost unbearable sentence, spoken by a real astronomer about this very void. Part 4. The civilization that would think it's alone. The astronomer Greg Aldring, considering the sheer scale of the Boötes Void, once put its meaning into a sentence that I have never been able to forget. He said that if the Milky Way had happened to sit at the center of the Boötes Void, we would not have known there were other galaxies until the 1960s. Sit with that for a moment, because it is one of the most quietly staggering statements in all of popular astronomy. He is not talking about some exotic alien species. He is talking about us. He is saying that if our own galaxy, with our own sun and our own Earth and our own history, had simply been located in a different part of space, our entire understanding of the universe would have been delayed by decades. And for most of our history, we would have believed that our galaxy was everything that existed. To feel the weight of that, you have to know how we actually learned otherwise, which is a story we will come to in full a little later. For now, hold on to the shape of Aldring's claim. The difference between knowing the universe is full of galaxies and believing your galaxy is the only one in existence does not come down to intelligence or technology or effort. It comes down to address. It comes down to where you happen to be standing when you look up. Move the Milky Way into the Boötes Void. Change nothing else. Keep every scientist and every telescope and every brilliant insight exactly the same, and the truth still slips out of reach for generations, because the light that would have revealed it is simply too far away and too faint to catch. Let me take you there, into that sky, and let you stand under it for a moment, because this is the center of everything tonight, and it deserves to be felt and not just described. You are standing on a world near the center of the Boötes Void. The ground beneath your feet is solid and ordinary. There is a sun in this sky during the day, warm and familiar, and the planet turns, and night comes the way it comes everywhere. When darkness falls, you look up, and the sky takes your breath, because it is full. Thousands of stars burn overhead, arranged in the patterns your people have named for thousands of years. A soft band of light arcs across the heavens, the glow of your own galaxy seen from the inside. Nothing about this night feels poor or empty. By every measure your eyes can offer, you live beneath a generous and beautiful sky. Then you build your first telescope, and you turn it past the stars, into the dark spaces between them, the way our astronomers once did, expecting, perhaps, to find faint companions to your galaxy out there in the black. And you find nothing. You look in one direction, and there is only dark. You turn the instrument, and look in another, and there is only dark. You build a larger telescope, and a larger one after that, and still the dark holds, mile after mile, year after year of patient searching, and nothing resolves out of it. There are no neighbours. There is no Andromeda hanging in your sky, as a faint warning that more exists. There is only your own galaxy, blazing and complete, suspended in an emptiness that gives back nothing, no matter how hard or how long you look. And slowly, reasonably, inevitably, your people arrive at a conclusion. The universe is one galaxy. It is yours. And beyond its edges lies an infinite, eternal, untenanted dark. That conclusion would not be a mistake. That is the part I need you to feel. Your astronomers would not have been careless. They would have looked as carefully as ours did, reasoned as rigorously, built their instruments as skillfully. They would have followed the evidence exactly where it led, with complete intellectual honesty, and the evidence would have led them to a false universe. They would have been right about everything they could see, and wrong about everything they could not, and from the inside there would have been no way to tell the difference. Their certainty would have felt exactly like knowledge, because it would have been built the same way knowledge is built, out of observation and reason and care. The only flaw would have been invisible, baked into the location itself, present before the first of them ever opened an eye. I find this almost unbearably moving, and I want to tell you why, because it is not really a fact about a distant void at all. It is a fact about what it means to know anything from the inside of a limited view. The void dweller is not a fool. The void dweller is a careful, honest, intelligent mind doing everything right and still arriving at a profoundly false picture of reality simply because the truth was placed beyond the reach of their senses by an accident of geography. And if that can happen to them, completely and invisibly, then the question that should be rising in you now is the one I have been steering toward all along. How do you know it is not happening to you? You cannot dismiss that question by pointing to your own full sky, because their sky felt full to them too. Their galaxy gave them thousands of stars and a beautiful band of light, exactly as ours does. The fullness of the nearby view tells you nothing about the completeness of the distant one. The void dwellers' nights were as full of stars as yours, and still their universe was a fraction of the real one. So the abundance you see when you look up is no guarantee at all. It is only proof that you live inside a galaxy, which you already knew. It says nothing about how much of the universe beyond your galaxy has been quietly kept from you. There is something else hidden in this thought experiment, something even stranger than the loneliness. The void dwellers' false universe would be internally consistent. Every measurement they made would agree with every other measurement. Their physics would work, their predictions would come true. They could build a complete, coherent, beautifully self-consistent cosmology in which their galaxy was the entirety of existence, and nothing in their data would ever contradict it because the contradicting evidence had been removed before the theory was ever written. This is the deepest unease the void offers. It is not merely that you might be missing something. It is that a missing piece can leave a picture that looks whole. Incompleteness does not always announce itself as confusion or contradiction. Sometimes it announces itself as a perfect, satisfying, entirely wrong sense of understanding. And before you comfort yourself with the thought that we, at least, got lucky, that we happen to live in a well-populated part of the cosmos where the neighbors are visible and the truth was within reach, I want you to hold on to a small, uncomfortable fact that we will return to before the night is done. We did not always know the universe was full of galaxies. For nearly all of human history, right up until about 100 years ago, the most careful and intelligent people alive believed something remarkably close to what the void dweller would believe. They believed that our galaxy might be the whole of creation, with nothing beyond it but empty dark. They were not in a void. Their sky was full of neighbors waiting to be found. And still they did not know, for the same reason the void dweller would not know, because the light that carried the truth was too faint for the instruments of the time to catch. We were the void dwellers once. We simply did not realize it. And the story of how we finally escaped that illusion is the story I want to tell you next. Part 5. We already made that mistake. For almost the entire span of human history, we believed something that now sounds astonishing. We believed that our galaxy might be the whole universe. Not one galaxy among hundreds of billions, but the single, total, complete extent of everything that existed, surrounded by an endless, empty dark. And we did not believe this out of ignorance or carelessness. We believed it because, just like the imagined void dweller, we could not yet see the evidence that would have told us otherwise. The neighbors were there, all around us, waiting in the sky. We simply could not reach them with the instruments we had. The faint smudges were the problem. For centuries, astronomers had been cataloguing strange, blurry patches of light in the sky that did not look like ordinary stars. They called them nebulae, from the Latin word for cloud, because that is what they resembled, little misty clouds scattered among the sharp points of the stars. Some of them were genuinely clouds, enormous formations of gas and dust within our own galaxy. But some of them, including the faint oval smudge in the direction of the constellation Andromeda, were something else entirely, and the question of what they were became one of the great arguments in the history of science. Were these spiral nebulae small, nearby clouds, inside our own galaxy? Or were they enormous, distant galaxies in their own right, separate islands of stars unthinkably far away? This question came to a head in 1920 in a famous exchange that historians now call the Great Debate. Two respected astronomers, Harlow Shapley and Heber Curtis, stood before an audience and argued the two sides. Shapley held that the spiral nebulae were relatively small and lay within our own galaxy, which he took to be essentially the entire universe. Curtis argued that they were separate galaxies, immense and remote, each one a stellar system comparable to our own. Both men were brilliant. Both marshalled the best evidence available. And the debate could not be settled, because no one yet had a way to measure how far away those smudges actually were. The truth depended on distance, and distance was exactly the thing no one could yet determine. Sound familiar? The entire question of how large the universe was came down, once again, to whether the relevant light was within reach of measurement. It was not, quite, and so the matter stayed open. Two careful interpretations of an incomplete sky, neither one provable. The person who finally settled it was Edwin Hubble, working at the Mount Wilson Observatory in California, where he had access to the largest telescope in the world at the time, the Great 100-Inch Reflector. And the way he settled it is worth standing inside for a moment, because it was one of the genuine turning points in the history of human understanding. It is a cold night in the early 1920s, and Edwin Hubble is at the 100-inch telescope photographing the Andromeda Nebula, that faint oval smudge, on glass plates through the long, patient hours of the dark. He is hunting for a particular kind of star, a kind that brightens and dims in a regular rhythm, called a Cepheid variable. These stars are precious because their rhythm reveals their true brightness, and comparing their true brightness to how faint they appear tells you exactly how far away they are. They are, in effect, mile markers scattered through space. Hubble compares plate after plate, looking for any point of light that changes. And then, on one plate, he finds it. A star inside the Andromeda Nebula, brightening and dimming in the telltale Cepheid rhythm. He measures its period. He works out its true brightness. He compares that to how faint it looks. And the distance that comes back is so enormous that it places Andromeda far, far outside our own galaxy. He goes back to an earlier plate where he had marked the object as a possible new star, crosses out his earlier note, and writes a single word above it in a moment that has become legend. He writes var for variable and an exclamation point. Var! Exclamation point. One small mark on a glass plate, and the universe multiplies overnight. Because that one star meant that the Andromeda Nebula was not a cloud inside our galaxy. It was another galaxy entirely, a separate island of hundreds of billions of stars, lying about 2.5 million light-years away, a distance so great that the number barely means anything. And if Andromeda was a galaxy, then so were the other spiral nebulae, all of them, the thousands upon thousands of faint smudges scattered across the sky. In an instant, the universe went from possibly being a single galaxy to containing countless galaxies, stretching out farther than anyone had dared to imagine. The cosmos had not changed. It had been full of galaxies the entire time. What changed was that, for the first time, a human being could finally see the evidence, because finally there was a telescope large enough and a method precise enough to catch the faint light that had been arriving all along. I want you to notice how exactly this maps onto the Void Dweller. We were not in a void. Our sky was full of neighbours, Andromeda hanging right there, visible to the unaided eye as a faint patch that humans had noticed for 1,000 years. The truth was not hundreds of millions of light-years out of reach. It was 2.5 million light-years away, close by cosmic standards, sitting in plain sight. And still, for the whole of human history, until that cold night, we did not know. We believed in a smaller, lonelier universe, not because we were foolish, but because the light that carried the truth was too faint for our instruments to read. We were the Void Dweller, in a milder form, separated from the truth not by an enormous emptiness, but only by the limits of our own eyes and our own machines. This is the part that should rearrange something in you. The difference between the Void Dweller's permanent ignorance and our eventual discovery was not a difference of intelligence or honesty. It was a difference of degree. The Void Dweller would be kept from the truth by hundreds of millions of light-years of emptiness. We were kept from it by a few decades of insufficient telescope power. In both cases, the obstacle was the same in kind, a gap between the faintness of the truth and the reach of the instrument. We happened to live somewhere, and to live late enough that the gap was small enough to finally close. The Void Dweller would not be so lucky, and the only reason we feel certain we have seen the whole picture now is that we have closed every gap we currently know how to close. But how would we know about a gap we cannot yet close? How would we recognize a truth still too faint for our best instruments to catch? That question opens onto something larger than the void, larger even than the question of distant galaxies. It opens onto the structure of the entire universe, and a fact that turns the whole story inside out. Because once Hubble had shown that the galaxies were out there, astronomers spent the following decades mapping where they actually sat, and what they found was not an even sprinkling after all. They found that the galaxies are arranged in a pattern, an immense and beautiful pattern, and that the emptiness of the Boötes Void is not a freak exception to that pattern. The emptiness, it turns out, is most of what the universe is. Part 6. The universe is mostly empty anyway. When astronomers finally built maps of where the galaxies sit in 3 dimensions, mapping not just their positions on the sky but their distances, using the same redshift technique that revealed the Boötes Void, they expected, perhaps, to find galaxies scattered more or less evenly through space, like grains of sand spread across a floor. That is not what they found. What they found was one of the most surprising and beautiful structures in all of nature, and it changed how we picture the universe at the largest scales. The galaxies are not spread evenly at all. They are gathered into a network, an immense web of threads and sheets and knots, with enormous empty spaces in between. Galaxies cluster together along long, thin filaments, like beads strung on cosmic threads. Where filaments cross, they form dense knots, the great clusters of galaxies, holding hundreds or thousands of galaxies bound together by gravity. Filaments connect into immense sheets and walls, 2-dimensional planes of galaxies stretching across hundreds of millions of light years. And in between all of this structure, occupying most of the room, are the voids, the great empty bubbles where almost nothing lives. Astronomers call this pattern the cosmic web, and once you have seen a map of it, you cannot unsee it. The universe, on the largest scales, looks unmistakably like a sponge or a network of soap bubbles or the branching threads of some enormous neural structure with matter strung along the surfaces and edges and emptiness filling the interiors. This structure first came into clear view in the 1980s through pioneering surveys, especially the one carried out at the Center for Astrophysics. In 1989, 2 astronomers, Margaret Geller and John Hutra, published a now famous map, a thin slice through the nearby universe, plotting the positions of hundreds of galaxies. The map stunned people because the galaxies did not fill the slice. They traced out delicate, intricate patterns with great dark gaps where no galaxies appeared. One feature in the map was so large it became known as the Great Wall, an enormous sheet of galaxies stretching across hundreds of millions of light years. And surrounding the walls and threads were the empty regions, the voids, taking up most of the space. People looked at that map and saw, for the first time, that the universe had a shape, and that the shape was mostly holes. Here is the number that reframes everything we have been discussing. By most estimates, the voids occupy something like 80% of the volume of the universe. 80%. The galaxies, the stars, the planets, all the matter we have ever cared about, all the structure and light and life, are concentrated into the remaining 20%, strung along the filaments and gathered into the walls. Most of the universe, by volume, is void. Most of the universe is the kind of emptiness we have been treating as a strange exception. The Boötes Void is not a freak. It is simply a large and well-studied example of the most common kind of place there is. Let this invert the picture you started the night with. You began by assuming the universe is full, with emptiness as the rare gap between the crowds. The truth is closer to the opposite. The universe is mostly empty, with fullness as the rare exception, the thin, bright skin stretched over an immense and mostly vacant structure. We do not live in a crowded cosmos with a few holes in it. We live in a cosmos of holes, threaded here and there with galaxies, and we happen to live on one of the threads. Our crowded sky is not the universe's default condition. It is a local privilege, a consequence of sitting on one of the rare bright filaments rather than out in one of the common dark bubbles. And this changes the meaning of the void dweller's situation in a subtle but important way. We have been imagining the void dweller as someone unlucky dealt a rare and unfortunate location. But if most of the universe by volume is void, then in a certain sense the void dweller's emptiness is not the unusual case at all. The unusual case is ours. We are the ones with the strange, privileged, neighbor-filled sky. If observers were scattered at random throughout the universe, by volume, more of them would find themselves in the emptiness than on the bright threads. The lonely sky might be closer to the cosmic norm than the crowded one, which means the illusion of an empty universe is not some rare trap that catches only the unlucky few. It might be the more typical view, and our full, reassuring sky might be the exception that happens to tell us the truth. There is a deeper lesson folded into the cosmic web, and it has to do with how structure and emptiness are related. The voids are not separate from the filaments. They are part of the same process. The matter that makes up the bright walls and threads had to come from somewhere, and where it came from is the voids. Over billions of years, gravity has been gathering matter out of the emptying regions and onto the growing structures, draining the voids to build the walls. The emptiness and the fullness are two faces of a single sculpting process, the slow gravitational organization of the universe. The void is not a place where matter is missing. It is a place where matter left, pulled away over eons onto the threads around it. The fullness we see is made of the same stuff that the emptiness lost. Understanding that requires us to ask how the process actually works, how a region of the early universe, which began almost perfectly smooth and uniform, could end up sculpted into this immense architecture of walls and threads and great empty bubbles. Because the early universe was not full of holes, the early universe, as far back as we can see it, was astonishingly smooth, almost featureless, the same in every direction to better than 1 part in 100,000. The cosmic web was not there at the beginning. It had to be built. And the story of how the voids were born is the story of how almost nothing became the largest structures in existence, starting from differences so tiny they could barely be measured at all. Part 7. Why the dark is so hard to read. There is an old puzzle in astronomy that turns out to be hiding underneath this entire story, and it is worth pulling into the light because it teaches the same lesson the void teaches from a completely different direction. The puzzle is almost childlike in its simplicity. Why is the night sky dark? You might think the answer is obvious. The sky is dark because the sun has gone down, and there is nothing up there at night but a scattering of stars. But the question is sharper than that, and the sharper version has troubled thoughtful people for centuries. Here is the sharper version. If the universe were infinite and eternal, and filled more or less evenly with stars in every direction, then no matter where you looked in the night sky, your line of sight would eventually land on the surface of some star. Near or far, in every possible direction, there would be a star somewhere along that line. And if every direction ended on a star, then the entire night sky should blaze with light, as bright as the surface of the sun, in every direction at once. There should be no darkness at all. The night should be an unbroken wall of fire. This puzzle is called Olbers' paradox, after the astronomer who popularized it, though others had wrestled with it before him. And the paradox is real. In a truly infinite, eternal, evenly filled universe, the night sky could not be dark. But the night sky is dark, so something about that picture must be wrong. And working out what is wrong took a long time, and the answer reaches into the very nature of the universe. The night sky is dark for two main reasons. The first is that the universe is not eternal in the simple sense. It had a beginning, around 13.8 billion years ago, which means light has only had a finite amount of time to travel. We can only see stars whose light has had time to reach us, and beyond a certain distance, there has not been enough time since the beginning for any light to arrive. The second reason is that the universe is expanding, stretching the light from the most distant sources until it fades and reddens beyond the range our eyes can see. Between these two effects, the wall of fire never assembles. The night stays dark, not because the universe is empty, but because of the limits of time and the stretching of space. Now hold that beside everything we have been saying about the void, because it sharpens the central point to a fine edge. Even in a universe absolutely packed with stars, the night sky would still look dark to you because of where you sit in time and because of how space behaves. Darkness, in other words, is a terrible guide to emptiness. A dark patch of sky might be empty, or it might be full of light that simply cannot reach you, stretched away or stranded beyond the horizon of time. From the inside, you cannot tell the difference by looking. The darkness looks the same either way. This is the same lesson the void teaches, arriving from the opposite side. The void teaches that a real emptiness leaves no mark, looking exactly like ordinary dark. Olber's paradox teaches that a real fullness can also look like ordinary dark when time and expansion get in the way. Put the two together, and you arrive at something genuinely unsettling. The darkness of the sky tells you almost nothing by itself about whether the universe out there is empty or full. Dark can mean nothing is there. Dark can mean everything is there, but you cannot reach it. The same black sky covers both, and your eye cannot distinguish them. The only way to know which kind of dark you are looking at is to measure, carefully, patiently, the way Hubble measured Andromeda and the way Kirshner and his colleagues measured the void, building the truth, one faint object at a time, because the raw appearance of the sky will not hand it to you. I think this is why the void unsettles people in a way that other astronomical facts do not. Most strange things in the cosmos announce themselves. A black hole bends light around itself in a way you can detect. A supernova flares to brilliance for weeks. An exploding star, a colliding pair of neutron stars, a flickering quasar, all of these reach out and make themselves known. But a void does the opposite. It makes itself known by withholding. It is a feature defined entirely by what is not there, and what is not there cannot send a signal, cannot wave for attention, cannot leave a fingerprint on a photograph. The void is the one kind of cosmic structure that is, in a real sense, made of silence. And silence is the hardest thing in the universe to notice, because it sounds exactly like everything else that is not making a sound. There is a strange comfort hidden in this, though, and I do not want to leave you only with the unease. The fact that darkness is hard to read is also the reason astronomy is a genuine science, and not just a matter of looking up and trusting your eyes. We do not learn the universe by glancing at it. We learn it by measuring it, by spreading light into spectra, by timing the rhythms of variable stars, by building three-dimensional maps from thousands of patient observations. Every real advance in our picture of the cosmos has come from refusing to trust the raw appearance of the sky and insisting instead on measurement. The void dwellers' tragedy would not be that they failed to measure. It would be that even their best measurements would come up empty, because there would be nothing within reach to measure. We are luckier. When we measure, the neighbors answer. But the discipline is the same, and so is the warning. Never trust the dark to tell you whether it is empty. Make it prove it, one faint point of light at a time. So the darkness of a void is not a sign that something went wrong there, not a wound or a scar or a place where the universe failed. It is simply a region that lost almost all its matter to the structures around it, leaving behind a dark that looks like every other dark. But that raises the obvious question, the one a curious mind cannot help asking. How does a region lose almost all its matter in the first place? How do you take a young universe that began nearly smooth and uniform, with matter spread evenly everywhere, and end up with enormous empty bubbles 330 million light-years across? The answer is one of the most elegant stories in all of cosmology, and it begins with differences so small they almost were not there at all. Part 8. How a Void is Born. To understand how the voids were born, you have to go back to the universe as it was when it was very young, only a few 100,000 years after the beginning, because that is the earliest condition we can actually see. We can see it because the light from that era is still arriving, stretched out now into a faint glow of microwaves coming from every direction in the sky, a kind of fossil light left over from when the universe first became transparent. We call it the cosmic microwave background, and it is the oldest light there is, a portrait of the infant cosmos. And when we examine that portrait, the first thing that strikes us is how astonishingly smooth it is. The early universe was nearly uniform. The fossil light shows that the matter was spread out almost perfectly evenly, the same temperature and the same density in every direction, to better than 1 part in 100,000. That is smoother than a billiard ball. If you had been there, you would have found no galaxies, no stars, no structure of any kind, just an almost featureless fog of matter and radiation, the same wherever you went. The cosmic web did not exist. The voids did not exist. There was only the smooth, warm, uniform beginning. And this presents a genuine puzzle, because the universe today is the opposite of smooth. It is sculpted into the most elaborate architecture imaginable. So where did the structure come from? How did almost perfect smoothness become walls and threads and great empty bubbles? The answer is that the smoothness was not quite perfect. That 1 part in 100,000 matters enormously. Scattered through the early universe were tiny differences in density, regions that were the slightest bit more crowded than average, and regions that were the slightest bit emptier than average. These differences were minuscule, almost nothing, the faintest ripples on an almost flat sea, but they were enough because of the patient, relentless, amplifying power of gravity. Gravity is an instability. Where there is a little extra matter, gravity pulls in a little more, which creates a little more gravity, which pulls in still more. The slightly crowded regions grew steadily more crowded as their gravity drew matter toward them, and the slightly empty regions, losing the gravitational competition, grew steadily emptier as their matter drained away toward the growing crowds around them. Over billions of years, the tiny ripples were amplified into the immense structure we see today, the crowded growing more crowded, and the empty growing emptier on a cosmic scale. This is the crucial thing to understand about a void. A void is not a place where something scooped the matter out. A void is a place that started with slightly less matter than average and then lost the tug of war. Over billions of years, its sparse matter was gradually pulled away by the denser regions surrounding it, drawn out onto the filaments and into the walls, until the region was left almost empty. The void did not have its contents removed. Its contents left, slowly, of their own gravitational accord, migrating to the structures around the edges. The Boötes Void is empty today because, long ago, it began very slightly emptier than its surroundings, and gravity did the rest, patiently, over the entire history of the universe. There is a beautiful detail here that makes the picture even clearer. The voids do not just passively lose matter, they actively expand. Because a void has less matter than average, it has less gravity than average, which means it cannot hold on to its contents and cannot resist the expansion of the universe as well as denser regions can. So the voids grow. Matter flows outward from their centers toward their edges, and the empty bubbles swell over time, pressing against one another, their boundaries becoming the walls and filaments where the expelled matter collects. If you could watch the universe evolve in fast motion over billions of years, you would see the voids inflating like bubbles in rising dough, and the matter being squeezed into the thin films and threads between them. The cosmic web is, in a sense, the foam left behind as the voids expand and crowd together. The emptiness is not the absence of the structure. The emptiness is what builds the structure by pushing everything to the edges. This is why I can tell you, with real confidence, that the Boötes Void was not emptied by anyone. There is a fringe idea, and we will come back to it later in its own right, that a region this empty might have been deliberately cleared by some unimaginably advanced civilization harvesting its stars. It is a fun idea for a story, but it is not needed, and it does not fit. The voids are exactly what the laws of gravity predict, starting from the tiny ripples we can actually see imprinted in the fossil light of the early universe. We can run the calculation forward from those measured ripples using nothing but gravity and the known contents of the cosmos, and out come voids of just the right sizes and just the right emptiness, the Boötes Void among them. The Great Nothing is not a mystery of missing matter. It is one of the most successful predictions in all of cosmology, a place whose emptiness was written into the universe in its first moments and developed with perfect lawful patience over 13 billion years. And yet knowing how the void formed does nothing to soften the lesson it carries for the mind inside it. It does not matter to the void dweller that their emptiness is the natural and predictable result of gravity acting on primordial ripples. The sky is just as empty either way. The neighbours are just as far away, the dark just as complete, the false conclusion just as inevitable. Understanding the mechanism of the emptiness from the outside, as we do, is a privilege that depends entirely on our being able to see the full cosmic web for comparison, on our knowing that voids and walls go together, on our having measured the fossil ripples that seeded them all. The void dweller would have none of that context. They would have only their empty sky and their honest reasoning, and the two together would still deliver them a universe far too small. So we understand the void now, from the outside, as a lawful and predictable feature of a universe sculpted by gravity from nearly nothing. But there is a question we have been circling without quite landing on, and it is time to land on it, because it turns this whole story from a tale about a distant emptiness into something a great deal closer to home. We have been speaking of the void dweller as someone else, somewhere else, trapped in an illusion we are lucky enough to escape. But are we so sure we have escaped it? Are we so sure that we are standing on a bright, crowded thread of the cosmic web, and not somewhere quieter, somewhere emptier, somewhere that is editing our own sky in ways we have only just begun to suspect? Part 9. Are we standing in one? For a long time, it was comforting to assume that we live in a perfectly ordinary, average patch of the universe, sitting on one of the bright threads of the cosmic web, surrounded by a fair sample of neighbours. The cosmological principle, that idea that the universe looks the same everywhere, encouraged us to believe that our location was nothing special, neither unusually crowded nor unusually empty, just typical. And for the most part, on the very largest scales, that assumption holds. But over the last couple of decades, a growing body of evidence has suggested that our particular corner might not be so average after all. It suggests that we may be sitting inside a large, underdense region of our own, not a void as extreme as Boötes, but a significant emptiness nonetheless, a place quieter than the cosmic average. The evidence comes from counting galaxies over enormous volumes of the nearby universe and comparing the local density to the average density measured on much larger scales. Around 2013, astronomers Ryan Keenan, Amy Barger, and Lennox Cowie carried out exactly this kind of careful counting, and they found something provocative. The region of the universe around us, out to a radius of perhaps 1 billion light-years, appears to contain noticeably fewer galaxies than the cosmic average, by something like 20%. The structure they were tracing has come to be called the local hole, or sometimes the KBC void, after their initials. And if it is real, it is enormous, perhaps 2 billion light-years across, which would make it one of the largest underdense regions ever proposed, far larger even than the Boötes Void, though much less extreme in its emptiness. I want to be careful and honest here, because this is a live scientific question, not a settled fact. The existence and size of the local hole are still debated. Measuring the average density of the universe over such immense volumes is difficult, and different methods give somewhat different answers. Some astronomers find strong evidence for a large local underdensity, and others are not convinced it is as large or as empty as claimed. This is exactly how science is supposed to work, with careful people disagreeing over hard measurements and slowly converging toward the truth. But the very fact that it is a serious possibility, debated by serious researchers, should give you pause. Because for most of the last century, we simply assumed our location was average, and now we are not so sure. The assumption of typicality, the thing that made us feel safe from the void dweller's predicament, is itself under question. Consider what this would mean if it is true. It would mean that we are not entirely outside the situation we have been pitying. It would mean we are partway into it ourselves, living inside a region that is emptier than average, with a sky that is, to some degree, already edited by the underdensity around us. We would not be as badly off as the imagined dweller at the centre of the Boötes Void. Our underdensity is much milder, and we can still see plenty of neighbours. But the difference would be one of degree, not of kind. We would be standing in a quieter room than we thought, and the quiet would be subtly shaping what we hear. This is the moment in the night where I want you to feel the story turn and look back at you. We began with the void dweller as a distant figure, someone else, somewhere far away, trapped in an emptiness we had the luxury of observing from the outside. We pitied them, perhaps, or marvelled at their predicament. But the predicament was never really about them. It was always about the general condition of being an observer who can only see what their location allows. And now the evidence suggests that we, too, may be sitting in an underdensity, our own view shaped by our own emptiness, our own cosmology quietly tilted by where we happen to stand. The void dweller is not a cautionary tale about somewhere else. The void dweller is a mirror, and the longer you look into it, the more you see your own situation looking back. What makes this more than a philosophical worry is that it might actually be measurable. If we really do live inside a large, underdense region, it would not just affect how many galaxies we count. It would affect how we perceive the expansion of the universe itself. Inside an underdensity, the matter is being pulled outward toward the denser regions surrounding it, which means the local expansion would appear slightly faster than the true cosmic average. We would, in effect, be sitting in a region that is emptying a little faster than the universe as a whole, and that could subtly distort one of the most important measurements in all of cosmology, the measurement of how fast the universe is expanding. For years, that measurement has been giving astronomers a headache, a stubborn disagreement that refuses to go away, and some researchers think our local emptiness might be part of the explanation. That headache has a name, and it has grown into one of the sharpest unsolved problems in modern cosmology. It is the kind of problem that keeps careful people up at night, because two different ways of measuring the same quantity, both of them excellent, both of them refined over years, keep giving answers that do not agree, and no one is entirely sure why. And the possibility that the disagreement comes partly from our own address, from the particular emptiness we happen to inhabit, is exactly the void's lesson made quantitative. It is the suggestion that our location is not just hiding distant galaxies from us, but actively skewing the numbers we trust most. So let me tell you about that disagreement, because it shows the void's illusion working not on some imaginary alien, but on the real measurements that real cosmologists are arguing about right now. Part 10. The crack in the expanding universe. The expansion of the universe is described by a single number, one of the most important numbers in all of science. It tells you how fast the universe is expanding, how quickly the space between distant galaxies is stretching. Astronomers measure it in slightly awkward units, kilometers per second per megaparsec, but you do not need to worry about the units. You only need to know that there are two main ways to measure this number, and that they have been giving stubbornly different answers, and that the disagreement has become one of the central mysteries of contemporary cosmology. It is called the Hubble tension, named for the same Edwin Hubble who first measured the expansion, and it has been sharpening for years rather than resolving. The first way to measure the expansion is to look at the nearby universe directly. You find objects whose true brightness you know, like certain variable stars and certain kinds of exploding stars, and you use them as mile markers to measure distances, then compare those distances to how fast the galaxies are receding. This is the local method, the direct method, a modern descendant of exactly what Hubble did in the 1920s. When astronomers do this with great care, they get an expansion rate of around 73. The second way is to start from the early universe, from that fossil light of the cosmic microwave background, and use our well-tested understanding of physics to calculate what the expansion rate should be today. This is the early universe method, the indirect method, and when astronomers do this, they get an answer of around 67. Two numbers, 73 and 67, that should be identical because they are measuring the same universe, and yet they refuse to match. That gap might not sound like much, 73 against 67, but in the world of precision cosmology, it is enormous. Both measurements have become so refined, their uncertainties so small, that the disagreement between them is now extremely significant statistically, at a level that means it is almost certainly not just bad luck or measurement error. Something real is going on. Either there is some unknown ingredient missing from our physics, some new feature of the universe we have not yet accounted for, or there is something about our measurements or our location that we do not fully understand. And this is where the void comes back into the story, because one of the proposed explanations is precisely that we live in a local underdensity. Here is the logic. If we sit inside a large underdense region, like the proposed local hole, then the matter around us is being drawn outward toward the denser cosmic structures beyond, and our local patch is emptying a little faster than the universe as a whole. An astronomer measuring the expansion using nearby galaxies would catch that extra local speed and read it as a faster overall expansion rate. The local method would come out too high, not because the universe is really expanding that fast everywhere, but because we happen to be sitting in a region that is racing outward a little faster than average. In this picture, the 73 is a local illusion, inflated by our emptiness, and the true cosmic value is closer to the 67 that the early universe method delivers. The disagreement would not be a flaw in physics. It would be a consequence of our address. I have to be honest with you about where this idea stands, because intellectual honesty is the whole point of this channel, and the void deserves to be handled carefully rather than oversold. Most cosmologists do not think a local void is the full answer to the Hubble tension. For the underdensity to explain the entire gap, it would probably have to be larger and deeper than most measurements support, and it would create other problems that are hard to reconcile with what we see. The tension is still very much unsolved, and a local void is only one candidate among several and not the favourite. But it has not been ruled out as a contributing factor, and the mere fact that it is on the table is remarkable. The most distinguished cosmologists in the world are seriously discussing whether our view of the entire universe might be skewed by the particular emptiness we happen to live in. That is the void dweller's predicament, dressed in equations, debated at conferences, printed in the most respected journals. Step back and look at what this really represents, because it is extraordinary. We are not talking about a thought experiment anymore. We are talking about a concrete, ongoing scientific controversy in which one of the live possibilities is that our cosmic location is deceiving us, that the numbers we trust most about the universe are subtly wrong because of where we stand. This is no longer the gentle parable of an imagined alien under an empty sky. This is us, today, with our best instruments and our sharpest minds, confronting the possibility that the universe we measure is partly an artifact of our address. The void's lesson has come all the way home. It is no longer a story about how someone else could be fooled. It is a question about whether we are being fooled right now in the data we collect with the most advanced telescopes ever built. And notice the shape of the problem, because it is the same shape we have seen all night. The trouble is not that anyone made a mistake. Both measurements of the expansion are superb. The teams that produce them are meticulous. The trouble, if the void explanation is right, is that a perfectly correct local measurement can give a globally wrong answer, because the local sample is not representative of the whole. That is exactly the void dweller's situation. Correct reasoning applied to honest data, delivering a false picture of the universe, because the data are drawn from an unrepresentative patch. The void does not corrupt the measurement. It corrupts the assumption that the measurement is typical, and that assumption is one we can almost never check from the inside. So our own emptiness, if it is real, might be quietly bending our picture of the cosmos. But the local hole, large as it may be, is mild, only 20% underdense, a gentle dimming of the cosmic crowd. To find emptiness at its most extreme, the largest and deepest known absence in the entire observable universe, we have to look toward a strange cold patch in the oldest light there is, a spot that may mark the single greatest nothing we have ever found. Part 11. The greatest emptiness we have ever found. There is a patch of sky in the direction of the southern constellation Eridanus, the river, that has puzzled cosmologists since it was first noticed clearly in the early 2000s. When astronomers mapped the cosmic microwave background, that fossil light from the infant universe, they found that it was almost perfectly uniform, the same temperature in every direction to an extraordinary degree, with only the faintest ripples. But in this one region, there is a spot that is colder than it should be. Not dramatically colder, but colder than the random ripples can comfortably explain, a patch of the early universe light that seems too cool, too large, and too distinct to be a simple statistical fluke. It became known as the CMB cold spot, and it has resisted easy explanation for 2 decades. One of the leading proposals for what causes the cold spot is, fittingly for tonight, an enormous void. The idea works through a subtle effect involving how light behaves when it passes through a region of changing gravity. When light from the early universe travels across a large void on its way to us, it has to climb out of the shallow gravitational well as it enters and then fall back as it leaves. And because the universe is expanding the whole time, the void stretches during the light's crossing, and the light comes out with slightly less energy than it went in with. Slightly less energy means slightly cooler. So, a sufficiently enormous void lying between us and the early universe light could imprint a cold patch on the cosmic microwave background, a shadow of emptiness stamped onto the oldest light there is. And when astronomers went looking, they did find evidence of a large underdensity in roughly that direction, a supervoid, sometimes called the Eridanus supervoid, possibly around 1 billion light-years across. I have to add the honest caveat once more, because this is genuinely uncertain. Whether the Eridanus supervoid is real, and whether it is large enough and empty enough to fully explain the cold spot, is still debated. Some studies support the connection. Others find the proposed void insufficient to account for the full, chill, and alternative explanations, including the possibility that the cold spot is simply a rare but natural fluctuation remain on the table. But take the void explanation seriously for a moment, because if it is right, it points to an emptiness on a scale that dwarfs even the Boötes Void. 1 billion light-years is roughly 3 times the diameter of the great nothing we started with. It would be among the largest single structures, if you can call an absence a structure, in the entire observable universe. Let me take you there, the way I took you to the center of the Boötes Void, because the scale deserves to be felt and not just stated. You are floating at the center of a supervoid, roughly 1 billion light-years across. There is no ground here, no planet, no star nearby, only the enormous patient emptiness reaching out in every direction. The nearest great walls of galaxies, the dense structures that bound this emptiness, are so far away that their light has been traveling toward you for hundreds of millions of years before reaching this central point. In every direction you turn, the story is the same. Distance and more distance, and then, impossibly far, the faintest beginnings of the cosmic web, so remote that it seems less like a neighbor and more like a rumor. You are suspended in the largest stillness the universe knows how to build, a region where the word nearby has quietly lost all meaning, where even light, the fastest and most patient traveler there is, needs an eternity to cross from one edge to the other. There is no drama here, no danger, only an emptiness so complete that it bends the mind to hold it. And if you had been born here, near the center of all this nothing, your sky would be the emptiest sky any conscious being could ever look up into, and you would have no way of knowing that anything else existed at all. Hold that image, because it represents the far end of the spectrum we have been traveling along all night. We started with the Boötes Void, 330 million light-years of emptiness, severe enough to have hidden the universe from anyone living inside it. Now we have reached the possibility of supervoids 3 times larger still, emptiness on a scale that could leave its mark on the oldest light in existence. And across that entire spectrum, from the merely huge to the almost unthinkable, the same principle holds. Each void is a place where an observer would see less of the universe than is really there, and where the part they could not see would leave no trace, no warning, no shadow they could detect from the inside. The larger the void, the larger the missing piece, and the more complete and convincing the resulting illusion of a small and empty cosmos. There is something almost vertiginous about realizing that emptiness comes in sizes, that there is a hierarchy of nothing, from the gaps between stars to the gaps between galaxies, to these great supervoids that could span 1 billion light-years and chill the fossil light of creation. We tend to think of empty space as uniform, as featureless, as simply the backdrop against which the interesting things happen. But the emptiness has structure of its own. It has scales and degrees. It has its own geography of absence. And the deepest of those absences are large enough to function as cosmic blindfolds, capable of hiding most of existence from anyone unlucky enough to live at their hearts. So far, every emptiness we have discussed has been a matter of location, of where in space an observer happens to be. But there is another kind of emptiness coming, one that does not depend on location at all, one that will arrive for every observer everywhere, no matter how lucky their address. It is an emptiness that the expansion of the universe itself is slowly manufacturing, and it means that the illusion of a small and lonely cosmos is not only a trap that catches the unlucky few in the voids. It is a fate the entire universe is drifting toward, a darkness that is coming, in the fullness of time, for everyone. Part 12. The sky that will go dark for real. Everything we have said about the void dweller has assumed that the missing galaxies are missing because of where the observer sits. But there is a way for the galaxies to go missing that has nothing to do with location, a way that will eventually empty the sky of every observer in the universe, no matter how richly populated their corner is today. The cause is the accelerating expansion of the universe, driven by the mysterious dark energy that makes up most of the cosmos and its long-term consequences are among the strangest and loneliest predictions in all of physics. The universe is not just expanding. The expansion is speeding up. Distant galaxies are receding from us faster and faster as time goes on, carried apart by the relentless stretching of space. And the more distant a galaxy is, the faster it recedes. This means that there is a limit, a kind of horizon, beyond which galaxies are receding so fast that their light can never reach us. As the expansion accelerates, that horizon draws inward, and galaxies that are visible today will, over time, be swept past it, their light stretched and dimmed until it fades from view entirely. They will not explode, or vanish, or be destroyed. They will simply recede beyond the reach of our instruments forever, carried away by the swelling of space faster than their light can swim back toward us. Run that process far enough into the future, and the consequences are staggering. Over billions and then trillions of years, every galaxy, outside our own local group, which is bound to us by gravity and will not be torn away, will eventually cross that horizon and disappear. The galaxies will redden, dim, and fade, one by one, until the sky beyond our own merged local group is empty. A civilization arising in that far future, on some world orbiting some star in that distant epoch, would look out into the cosmos and see only their own galaxy, surrounded by an endless, untenanted dark. They would have no Andromeda to warn them, no neighbours, no faint smudges to chase with their telescopes. They would see exactly what the void dweller sees today, except their emptiness would not be a matter of unlucky location. It would be the natural condition of the entire universe by that age. And here is the part that should genuinely unsettle you, because it is not speculation, but a straightforward consequence of what we observe. That far future civilization, looking out at their empty sky, would have no way to discover the truth. The evidence that the universe was once full of galaxies, that it began in a hot, dense state and expanded, that there were ever neighbours at all, would have receded beyond their horizon, permanently out of reach. They could do everything right, reason perfectly, build magnificent instruments, and they would still conclude that their galaxy was the whole of creation, alone in an eternal dark. The expansion will have erased the evidence. The universe will have hidden its own history from everyone who comes late enough to it. The far future astronomer would be the void dweller again, but this time the void would be the entire cosmos, and there would be no truth left anywhere to find. Sit with the strangeness of our own position in light of that. We are living at a privileged moment in the history of the universe, a window when the galaxies are still close enough to see, when the evidence of the larger cosmos is still within reach, when an astronomer can still look out and discover that we are one galaxy among hundreds of billions. That window is closing. It is closing slowly, over timescales so long that they dwarf the current age of the universe. But it is closing. We happen to be alive early enough and located well enough to see the truth. The beings who come after, in the far future, will not be. They will inherit an empty sky and a false cosmology, and they will have no way to know what they have lost, because by then it will not even register as lost. It will simply be absent, and absence leaves no mark. I find something almost unbearably poignant in that, and I want to name it rather than rush past it. We are not just observers of the universe, we are observers at a particular moment in its life, and that moment is one of unusual clarity, a brief season when the cosmos is still legible, still full of visible evidence about its own nature. We did not earn that, we did not choose it. We simply happened to arrive during the readable chapter, before the expansion carries the pages away. The far future astronomer's tragedy is not that they will be less intelligent than us. It is that they will arrive too late, when the universe has already drawn its own past beyond the horizon, and the most basic truths we take for granted will have become permanently undiscoverable. We are reading a book that is slowly closing, and we are lucky enough to be reading it while the words are still on the page. This casts the whole night in a new light. The Void Dweller is not an exotic special case after all. The Void Dweller is what every observer becomes, eventually, given enough time and the relentless work of the expansion. Emptiness is not just a feature of certain unlucky locations in space. It is the destination of the entire universe, the condition toward which everything is drifting. The illusion of a small and lonely cosmos is not a rare trap. It is the future, arriving on schedule for everyone. And that means the question we have been circling is even more urgent than it first appeared, because the forces that create the illusion are not confined to distant voids. They are operating everywhere, all the time, including here, including now. So before we draw all of this together, I want to give honest attention to the stranger explanations people reach for when they encounter emptiness on this scale. The theories that go beyond the careful science, into speculation, and sometimes into something close to conspiracy. Because when a region of space is empty enough, the mind starts to wonder whether the emptiness is natural at all, or whether something or someone made it that way. Part 13. The illusions we cannot rule out. Whenever people encounter an emptiness this profound, a region where almost everything that should be present is simply gone, the imagination reaches for an author. Surely, the thought goes, something this empty cannot be an accident. Surely someone, or something, made it this way. And so, a small constellation of alternative explanations has grown up around the great voids, ranging from serious scientific proposals that turned out to be wrong, to genuine fringe speculation, to ideas that drift toward conspiracy. I want to walk through them honestly, because the channel has always treated strange ideas with curiosity rather than contempt, and because seeing exactly why they fail is one of the best ways to appreciate what the science actually says. The most colourful idea is that a void this large was deliberately emptied. Perhaps, the speculation goes, an unimaginably advanced civilization, the kind that could harness the energy of entire galaxies, harvested the stars of the Boötes Void, dismantling them for resources or energy until the region was swept nearly clean. It is a wonderful premise for a story, the cosmic equivalent of strip mining a continent, but it does not survive contact with the evidence. We can calculate, from the tiny density ripples imprinted in the fossil light of the early universe, exactly what voids should form under the action of gravity alone, and the answer matches what we see. The Boötes Void is precisely the size and emptiness that the laws of gravity predict, with no engineer required. To explain it with a star-harvesting civilization, you would have to ignore the fact that the natural explanation already works perfectly and that voids of just this kind appear throughout the universe in exactly the numbers the physics predicts. Emptiness. This complete is not a sign of intervention. It is the ordinary handiwork of gravity, given billions of years. A more serious idea, one that real cosmologists genuinely pursued, is that we live inside a large void, and that this, rather than the mysterious dark energy, is what makes the distant universe appear to be accelerating. This is the family of models, sometimes called Hubble bubble cosmologies, built on a kind of geometry that allows the density of the universe to vary with distance from us. The appeal was real. If we sat near the center of a giant underdensity, the way the local expansion would differ from the distant expansion might mimic the effect we attribute to dark energy, and we could perhaps explain away one of the deepest mysteries in physics without invoking a strange, repulsive energy at all. It was a legitimate scientific hope, and people worked hard on it. But it ran into serious trouble. For one thing, it would require us to sit very near the exact center of an improbably large and symmetric void, which sits uncomfortably with the principle that our location should not be special. For another, and more decisively, the models conflict with the exquisitely uniform cosmic microwave background and with other precise measurements. The careful work was done, and the verdict came back. We cannot explain away dark energy by hiding inside a void. The void as dark energy idea is a beautiful example of a reasonable hypothesis that the evidence rejected. There is a third framing, and this one is not fringe at all, but actually true, and I include it because it shows the void in a kinder light. Because a void has so few galaxies in the foreground, it offers an unusually clean line of sight for looking at the distant universe beyond it. A region with fewer nearby galaxies means less light and less matter in the way, less foreground clutter to subtract a clearer window onto whatever lies behind. In this sense, the emptiness is not just an obstacle. It is an accidental telescope, a place where the universe has conveniently cleared the foreground for us. Astronomers really do think about the distribution of nearby structure when planning certain demanding observations. The emptiness that would blind an observer living inside it can, paradoxically, sharpen the view of an observer looking through it from outside. Whether emptiness hides the universe or reveals it depends entirely on whether you are inside it or looking across it, which is, when you think about it, just the vantage point lesson wearing a different coat. And then there is the strangest framing of all, the one that drifts from science into something more like philosophy or even unease. The idea that a void might be a place where reality itself is somehow thinner, a region where, if you took the simulation hypothesis seriously, the universe simply did not bother to render much detail. I mention this not because there is any evidence for it, because there is none, but because it captures something about how the emptiness makes people feel. A void, this complete, this silent, this featureless, can give the uncanny impression of an unfinished canvas, a part of the painting the artist left blank. But this is a feeling, not a finding. The void is not thin reality or unrendered space. It is ordinary space, governed by exactly the same laws as everywhere else, containing exactly the matter that gravity left behind. The emptiness feels like a sign of something missing behind the curtain. But the only thing missing is the matter, and we know precisely where it went. It went to the walls and the threads, pulled there over billions of years by the patient hand of gravity. What unites all of these alternative readings is the same impulse, the refusal to believe that something so empty could be natural and meaningless. And what the science keeps gently insisting, against that impulse, is that the emptiness needs no author, no conspiracy, no thin patch in the fabric of reality. The honest truth is stranger and quieter than any of the dramatic alternatives. No one emptied the void. No one is hiding the rest of the universe from anyone. The emptiness does all the hiding by itself, for free, simply by being large, because an absence asks no one's permission and leaves no mark. The most unsettling thing about the void is not that someone made it, it is that no one had to. But there is one more turn to make before we draw this together, and it is the turn that takes the void's lesson and aims it not at distant emptiness, but at the very ground beneath our feet. Because so far we have talked as if our problem were only the things that distance and emptiness hide from us. But even here, on our bright, crowded thread of the cosmic web, with neighbours all around and the universe seemingly laid open before us, there is a great deal we cannot see. And the universe we think we know is, in truth, only the universe we have so far been able to catch. Part 14. Everything we still cannot see. It would be comforting to think that the void's illusion is something that only happens far away, in the emptiest corners of space or the deepest reaches of the future, and that here, in our well-populated neighbourhood, with our advanced telescopes, we see the universe more or less completely. But that comfort does not survive a close look at how we actually know what we know. Even on our bright thread of the cosmic web, surrounded by visible neighbours, The universe we have mapped is only the part we have managed to detect, and the history of astronomy is in large part the history of discovering things that were there all along, waiting beneath the threshold of our instruments. Consider the most staggering example, the one that should humble anyone who thinks we see the universe as it is. When astronomers add up all the matter they can detect, all the stars and gas and dust in all the galaxies, and then compare it to how much matter the universe must contain based on how galaxies move and how structure formed, the numbers do not match, and they do not match by an enormous margin. The matter we can actually see, the ordinary matter that makes up stars and planets and people, accounts for only a small fraction of the total. The rest, something like 85% of all the matter in the universe, is invisible to us. We call it dark matter, and we have never seen it directly. We know it is there only because of its gravity, because of the way it pulls on the things we can see. The universe is mostly made of something we cannot detect with any telescope, something that hung in our own galaxy and every other galaxy the entire time we were drawing our careful maps, leaving no mark on any photograph, revealing itself only through its gravitational pull. We were the void dwellers again, surrounded by an immense presence we could not see, and we did not know it until the numbers refused to add up. Even among ordinary visible galaxies, the ones made of normal glowing matter, we have repeatedly discovered that we were missing things. For decades, astronomers catalogued galaxies by looking for bright, concentrated patches of light, and they built their picture of the universe from what stood out against the dark. But it turned out that there is an entire population of galaxies that are spread out and faint, so diffuse that they barely rise above the brightness of the night sky itself. These low-surface brightness galaxies were systematically overlooked, not because they were not there, but because our methods were tuned to notice the bright and ignore the dim. When astronomers finally went looking for them deliberately, they found a great many, an entire category of object that had been hiding in plain sight, missed not by distance or emptiness, but by the simple fact that our surveys were built to catch a certain kind of light and were blind to the rest. This is the pattern that runs through the whole history of astronomy. Every time we built a new kind of instrument, sensitive to a new kind of signal, the universe turned out to be fuller and stranger than we had thought. When we learned to see in radio waves, we found galaxies blazing with energy that were invisible to ordinary telescopes. When we learned to see in X-rays, we found the hot gas between galaxies and the violent regions around black holes that no optical telescope had revealed. When we learned to detect the ripples in space-time called gravitational waves, we began to hear collisions between black holes that emit almost no light at all, events that had been happening throughout cosmic history with no one able to notice them. Each new sense revealed a universe that had been there all along, sending signals we simply had no way to receive. The cosmos was never as empty or as quiet as it seemed. We were just deaf to most of its voices. So, the lesson of the void is not really about voids at all. The void is just the clearest, most dramatic instance of a principle that applies everywhere, to every observer, all the time. The principle is that the universe you know is the universe you can detect, and the universe you can detect is always smaller than the universe that is actually there. Your instruments define your reality. The galaxies you can see, the matter you can measure, the signals you can receive, these draw the boundary of your known cosmos, and everything beyond that boundary, whether it is hidden by distance, by emptiness, by faintness, by the wrong kind of light, or by the limits of time, simply does not appear. It does not show up as a gap or a question mark. It shows up as nothing at all, indistinguishable from a universe in which there was never anything more to find. This is why the void dweller's predicament is not exotic but universal. We are all void dwellers, to some degree, all the time. We all live inside the boundary of what our location and our instruments allow us to perceive, and we all face the same fundamental impossibility, the impossibility of seeing what we cannot see, of measuring what leaves no signal, of detecting an absence that looks exactly like the way things were always meant to be. The void simply makes this condition large enough and stark enough that we cannot look away from it. It takes the quiet, constant limitation that shapes all observation and blows it up to the scale of 330 million light-years, until we are forced to confront the thing we usually manage to ignore. The map is never the territory, and in astronomy, the map is made entirely of what we could catch. So now we can finally ask the question the whole night has been building toward, and ask it with the full weight it deserves. If emptiness leaves no mark, if absence is invisible, if the universe we know is only the universe we can detect, then why does the sense of a complete and finished cosmos feel so utterly convincing? To the void dweller, to our ancestors, to the far future astronomer, and to us, right now, tonight, why is an empty universe, or a partial one dressed up as a whole, the single most convincing illusion that physics has ever produced? The answer pulls together everything we have walked through, and it is, I think, both humbling and strangely beautiful. Part 15. Why empty is the most convincing illusion. The reason an empty universe is the most convincing illusion in physics comes down to a single, quiet fact that we have circled all night, and it is time to state it plainly and let it settle. An absence leaves no mark. Every other illusion the universe offers eventually betrays itself, because it puts something in front of you that is not what it seems, and a thing that is present can be examined, questioned, and eventually understood. But emptiness offers you nothing to examine. It does not place a false image before your eyes. It simply withholds the true one, and withholding leaves no trace. There is no false galaxy to catch in the act, no misleading light to decode, no anomaly to chase down. There is only the dark, looking exactly as dark is supposed to look, telling you nothing, and feeling, for that very reason, like the complete and honest truth. Think back over the 3 observers we have stood beside tonight, because they are really one observer wearing 3 different faces. There is the dweller at the center of the Boötes Void, gazing past their own galaxy into an emptiness that hides thousands of others, concluding they are alone. There are our own ancestors, a century ago and before, looking up at a sky that held Andromeda in plain sight and still believing our galaxy might be all there was, until one cold night and one variable star multiplied the universe overnight. And there is the far future astronomer, arriving after the expansion has carried every other galaxy beyond the horizon, inheriting an empty sky and a false cosmology with no way left to discover the truth. 3 observers, separated by hundreds of millions of light years and by billions of years of time, and every one of them honest, careful, intelligent, and wrong in exactly the same way. Not wrong because they failed, wrong because the truth was withheld, and withholding leaves no mark. I asked you, at the very beginning of tonight, to notice that you trust your sky. You trust that what you see is a fair sample of what is there, that your window onto the cosmos is an ordinary window, that the fullness you perceive is the fullness that exists. And I want to return that phrase to you now, changed by everything we have walked through. You trust your sky, and you should, because it is an honest witness. But honesty is not the same as completeness. Your sky reports faithfully every photon that reaches it, and says nothing whatsoever about the photons that do not. It is a truthful account of an edited reality, a faithful witness to only the part of the universe, your location, and your instruments, and your moment in cosmic time happen to permit. The sky does not lie to you. It simply cannot tell you what it was never given to say. And the most honest sky in existence is still only as complete as the universe allows it to be. Remember what Greg Aldering said, that if our galaxy had sat at the center of the Boötes Void, we would not have known there were other galaxies until the 1960s. I have been turning that sentence over all night, and here, at the end, I think it means something larger than it first appears. It is not only a fact about one unlucky location, it is a statement about every observer everywhere. Each of us is always some number of years away from the next thing we cannot yet see, the next truth waiting just beyond the reach of our current instruments, the next Andromeda hanging in plain sight that we have not yet learned to recognize for what it is. The void dweller's weight would have been measured in decades or centuries. Ours, for the things still hidden from us, might be measured in years, or in the building of one more instrument, one more kind of sense. But the situation is the same. There is always a next discovery that the universe is currently withholding, and from the inside, before we make it, that withheld truth looks exactly like nothing at all. This is why I find the void, in the end, not frightening, but clarifying. It does not teach us that the universe is cruel, or that knowledge is hopeless, or that we should distrust everything we see. It teaches us something gentler and more honest, which is humility about the edges of our knowing. We have learned, over and over, that the cosmos is larger than our instruments could show, fuller than our maps could capture, stranger than our certainties allowed. Every time we built a new kind of eye, the universe was waiting on the other side of it, having been there all along. The void simply reminds us that this process is not finished, that there are almost certainly truths around us right now, leaving no mark, waiting for the instrument or the insight that will finally let them appear. The history of astronomy is the history of absences becoming presences, of darkness resolving, one patient measurement at a time, into something that was there the whole time. And there is a strange tenderness in our particular moment, which I want to leave you with. We happen to live in a readable chapter of the universe, early enough that the galaxies are still close enough to see, located well enough that the neighbours are still visible, equipped at last with instruments good enough to have learned that we are one galaxy among hundreds of billions. We are not the void dweller, trapped in a permanent emptiness. We are not yet the far future astronomer, inheriting a sky already swept clean. We are here, now, in the season when the cosmos is still legible, still offering up its evidence to anyone patient enough to measure it. That is not nothing. That is, in fact, a kind of extraordinary luck, the luck of arriving while the book is still open and the words are still on the page. So when you next step outside on a clear night and look up at that scattering of stars, let yourself feel both things at once, because both are true. Feel the honest fullness of what you can see, the thousands of suns, the soft band of your own galaxy, the faint smudge of Andromeda, if your sky is dark enough, real light from a real neighbour 2.5 million years on its way to your eye. And feel, beneath that, the quiet immensity of what you cannot see, the dark matter threaded invisibly through it all, the galaxies hidden by distance and faintness and time, the voids holding their silence, the truths still waiting for an instrument we have not yet built. Your sky is honest. Your sky is also incomplete. And holding those two facts together, gently, without needing to resolve them, is as close as any observer ever comes to seeing the universe as it really is. The last question is the one I cannot answer for you, and the one I think is worth carrying with you as you drift off tonight. Somewhere out there, leaving no mark, casting no shadow, sending no signal we yet know how to receive, the universe is almost certainly keeping something from us, not out of malice, not out of design, but simply because absence is the easiest thing in existence to hide. We do not know what it is. We cannot, by definition, point to where it is missing. But if the whole long story of our looking has taught us anything, it is that the dark we are most certain is empty is precisely the dark most likely to be full. So rest now, under your honest and incomplete sky, and let yourself wonder, softly, as sleep comes. What is your sky, right now, simply not showing you, and how much larger and stranger and fuller than you can presently see, is the universe quietly waiting to turn out to be.